We are on the section 2.2, derivative, page 24. Let's talk about what is derivative first. So let's see. We are going to introduce some other concepts, then talk about the derivative. So let's talk about something called average and instantaneous rate of change, right? So when we talk about certain concepts, then let's look at some example. So for average, if you travel, okay, from point A to point B, and take so much time, say T time, right? So what you have is from point A to B, then what's the distance? Then you divide it by time, that would be your average speed, right? So if it takes time T, then your average would be so the average would be what? So you count your average, then you find your distance, right? The difference between that divided by your time. That would be your average. So if I look at another thing, then it's a little bit abstract. So if I take h time over that point, right? If my y is from here to another y here, okay? So what are we talking about? We are talking about things like this, okay? So if you have, right, from point this time to the h time later, right? So from time x to the time x plus h, that means you take h time to get there, right? So then if the beginning distance, say you are at the location f of x at the time x, that's your location, right? So at the time h, say h minutes, h hour later, so you are at the distance at here, right? So you are doing is from point A to point B, right? Then you take time from x to x plus h. So it's a little bit abstract for you, but you start to learn the different kind of thinking and symbol. So you go from here, right? So what we did is from the time x, okay, from the position, it's your position from f of x to where? F second point, right, from A to B. Then take what kind of time? From time here to there, right? So take time is h, right? Then what is your average? It's a difference, the distance is this one, right? F of x, second point minus what? Your starting point, right? Then averaged by the time is from beginning of the time to the time you arrive the second spot. So this difference is what? The time you started. Then this difference will be what? F, the second point minus the starting point. Okay? From A to B. On your notes, I wrote the opposite here. You need to switch them. So what are we talking about? The average. So average is you have the total distance divided by time. That would be your average speed, right? From point A to point B. So x is your first point, then f of x become your first location, and second location minus the first location, and divided by time. So average is handled this way. Then let's take a look if we do the definition more formally. Okay, so let's see. We talk about average rate of change. So when you find the average, then average rate of change, that means average, right? So between x to x plus h, then this is the difference in time is what? Is h, right? So the average, this is the difference in time. We just use time, so it's easier for you to comprehend. So difference in time, then from first location to the second location. So the average would be what? Your second location minus first location, the difference, the distance divided by time, right? So this would be your average for each time, right? So you count the average during that period of time. Next one, we are going to talk about instantaneous rate of change. This one is average rate of change. During that period of time, what's the average? Okay? Next one, we are going to talk about instantaneous. What does that mean? Instantaneous rate of change means what? At that instant, okay? So change at the instant in time, okay? So that means if I want to find the rate of change, instant change at this point, at X point, right at that instant, instead of average according to that time. So if the instant finding at the time at X, right, is what? When you are very close to X, and it happened at that instant quickly. So when it happens in that instant quickly, that means what? Our edge just right past the x. That means the difference of time just right after, not much time passed by, right? So that means h is very close to 0. So we use this way, we use the concept of a limit. So when h is close to 0, so instead that's your average, right? So according to the average, but when h is very small, so instead of time passed by a long time, just right at that moment. So that's the limit concept we use. And another thing we wanted to talk about is called the slope of the tangent line. We are introducing a few concepts with different explanation. Okay, so what is the slope? You know the slope, right? You learn in your algebra class at the beginning. Then the slope is what? Take a look. Okay, so if I have graph like this, and I'm going from here to there, right? So this is my starting point, f of x. Say, this is my f of x, my location, according to my time at x time. Then when after h, say h hour later, I'm here, right? H hour later, then I'm at the second location. So the difference of y here, right? That's your difference of y. y2 minus y1, right? Then this one will be difference of x, right? We say slope is what? y2 minus y1 divided by x2 minus x1. So x2 minus x1 is h. So what's the slope? And the tangent line. What is a tangent line? Tangent line, if you look at your page, concept is not as simple. If you look at your page 28, we describe what's the tangent line. Okay? Tangent line is at this point, looks like this. Just for the moment, we use this. Okay? Tangent line almost looks like this. Tangent line at that point, close to that point, and this tangent line only cross the curve one time. Just like if you threw a rope, right? You threw, then when you release the rope, then rope will fly out certain way, right? When I touch you, then just fly out along the tangent line. That's the concept of tangent line. Isn't that simple? You can read it through the page 28. Okay, so almost perpendicular to the center of the curve at that point in time. So if you talk about what is the tangent line for that, we say m is what? Slope is rise over run, right? Rise is what? The difference between the y. The run is the difference between the x. So for your, that's your slope, right? So for this one, the tangent line, the slope of tangent line becomes what? The difference of y over the difference of x. That would be h. So that's the slope, right? At this, how do we calculate at this point? So the slope of tangent line, but we are talking about the slope just from here to here. Actually, the line looks like this. But when h is very close to the x, then it becomes a tangent line at that point. So we write it this way, and it becomes the slope of tangent line at the number at this point at the time, right? Because we are talking about at that point. So at that point in time, h will approach to 0, very close to x, right after at the x time. Okay, so we introduced 3 concepts. So one is what? Average rate of change. Another one, average rate of change, right, is what? The difference between y over difference between x. The instantaneous rate of change at that instant, then you apply the concept of limit. That means h approach to 0. Then at the same time, if we think about slope of the tangent line at the point x, because every point has different tangent line. So we are talking about the tangent line close to the point x. That means h is approaching to 0. So if we look at this, are those two the same? Right? So what we are talking about, okay, the instantaneous rate of change is same thing as the slope of the tangent line at that point at time x. Then we will explain how things work out together later. So we introduce those concepts first. Let's see some examples on instantaneous rate of change. This one. Okay, let's practice the skills first. Then we see what's the meaning of it. So on your page 24, the example down below, it says find the instantaneous rate of change of the temperature function. If you have temperature function like this, f of x equals x squared at the time x equals 1. Okay, so we say what is instantaneous rate of change formula? That's that one, right? So, but the function, instead we use general function. Now function is x squared. So if we apply this formula, we are just learning the skills, then how to apply, not applying not applying yet. We just practice the skills, how to find the something called instantaneous rate of change. Then we use this formula, right? Apply to this function. So formula says you do this, right? So what would that be? Now your function is what? X squared. Then x plus h apply to function f. That means function f say, whatever you give to me, I square you, right? Now it's given by what? X plus h. So you square it. That's how you plug in. Then f of x is your x squared, right? Some of you have problem with plugging f of x, okay? So we practice that in your algebra class. Remember composite function when we plug in? Okay, so it's like this. Then we simplify. So this one, don't give me x squared plus h squared, right? You need to FOIL, then become what? 2xh plus h squared, right? Then, so you minus x squared, then what do we have? You simplify the top, so that's what you have, 2xh plus h squared. So when we find the limit, we say, we just use the rules, directly apply, plug in, if we can. For this instance, can we directly plug in h equals 0? Not really, because it will make the denominator 0. So what do? We say we can try to simplify first, right? So you will have, this one will be, if you simplify it, what do we have? Factor, right? Then you cancel out your h. Then you will have this one, your h approach to 0, and we have 2x plus h, right? We try to find the limit. So can we directly plug in now? Yes, right? So you end up, h is 0, you end up with what? 2x. So we find that the limit is 2x. What was the question? Question is saying find the rate of instantaneous rate of change at the time x is 1. That means at the time x is 1. What's your limit? Limit is 2x. So your limit is what? 2x. You plug in 1, so your limit is 2. That means the temperature function, if it's given by that, temperature function is given by x squared, right? And 1 is 1, 2 is 2, right? Then 1 is 1, 2 is what? 4. That's the x squared function. Then what we are talking about, actually that's a temperature curve. If it grows, okay, by a quadratic function, that means it goes up. Then it asks you what's the instantaneous change at time 1. So if at time 1 you have a 1 square, 1 degree, then at time 4, if it's a 4 degree, right, 2 square, 4 degree, that means at the time 1, what is instantaneous rate of change? That means you will go up 1 degree quickly, instantly, at the time 1. That's what it means. Little bit idea, get a little bit idea about, instant thing. Now let's take a look the page 25. Another example, finding the slope of the tangent line. Okay, so if I give you a line, f of x equals what? 1 over x. At the time x is 2. All right, let's just follow through, then see what does it mean. Okay, take a look. So we say find the slope of tangent line. You use the formula. So you have what? Limit h approach to 0, follow through this, f of x plus h minus f of x and h, right? Then you plug in limit, you plug in x plus h in terms of x place. So that would be, right? F says whatever you give to me, I'm going to do the reciprocal. So you are given x plus h. So you are doing the reciprocal on that. Then minus x over h, right? We cannot plug in h. Then what? Let's just simplify it. Simplify this thing and see we can get somewhere. How do we do it? How do we simplify it? That's how you do. Okay, so let's see. 1 over x plus h. What do we have? We have a complex fraction. Fraction within fraction. In your algebra class, we simplify this complex fraction, right? So how do we do? And we say we will rewrite it. This big line means what? Division, right? Then you will divide it by h. Then you simplify two fractions, become one fraction by doing what? Find your LCD, which is, this is in your algebra class, we learned it in your 152B class. So this one, x is extra, so you x, right? You multiply. This one, x plus h is extra, so you times this, right? Then you combine it, become what? One single fraction, x minus what? X plus h, right? Then you simplify it, becomes what? You will have this. Then x, this would be what? X minus h. You need to distribute your negative number, right? So what do we have? So we have h, negative h. On the top, bottom will be like this, right? This is just a first fraction. Then divided by h. Then how do we do that? To divide, we multiply its what? Reciprocal. This is h over 1, become what? 1 over h, right? Then what do? We simplify it. Then what do we have? We will have a negative 1 on the top, x and x plus h on the bottom. A complex fraction, then we simplified it to a single fraction. Okay, so what happened here? We simplified our fraction, so it becomes negative 1 x plus h, right? Then we try to find the limit. Can we plug in now without making the denominator 0? Take a look. We can do that because when you plug in h is 0, the bottom is no longer the 0, right? So what do we have? We will have plug in 0, right? Then we take care of the limit part. So whatever left, that will be what? Only this is a 0, right? And so become x times x, become x squared. The top what is negative 1. So the limit is this way. So for this tangent line, then we find the limit. Then it's this equation. What does that mean? It says x at 2, then what's your limit? What's your slope of tangent line? It means what? The limit at this point, you plug in x equals 2. So what do you have? 1/4. So 1 to the 2 squared becomes negative 1/4. Okay, so what does this one tell us? We are finding the tangent line, and tangent line is the same thing as instantaneous change at that point. Okay, so if we graph f of x equals 1/x, right? You do your t-table, x, y is 1/x. We cannot do 0, right? When x is 1, that would be what? 1/1 is 1, is 2, would be 1/2. And when it's very big, it goes to 0, okay? So the graph looks like this. X is 1, that would be 1, 1. X is 2, that would be what? Half, right? Then half will be 2. So half will be 2, right? So then 3 would be what? 3 would be 1/3, like this. And negative would be here. You use your calculator to see it, to see the graph. So it's saying at x equals 2, the rate of change, the tangent line looks like this. As this one, this, right? Cross this point, only touch one point at a time. Then what is the slope? So if the slope goes up from left to right, it's what? Positive. If it goes down, it's what? Negative. That's in your algebra class, 152A, we talk about that. Then here say the limit is negative 1/4 at the point x equals 2. What it's saying is the tangent line, the slope of tangent line is what? Negative 1/4. That's a negative line. And at that point of time, it has tendency, it is, and to change right away to drop 1/4 at a time. That's what it's saying. Previously, we talked about what? Average and instantaneous rate of change. The instantaneous rate of change is derived from the concept of average. Then at the same time, we talk about what? The slope of tangent line at that point, it's the same formula as we have instantaneous rate of change. Remember the limit, right? Then with the fraction behind it. Now we are going to talk about another term, something called difference quotients. Okay? So difference quotient is given to you. Okay? It's we're not talking about concept. We are talking about definition. It's given to you. We use this term, then we define it mathematically. We say, okay, something called difference quotient is written like this. Does this look familiar? Right? This is a quotient. Then this is a difference. So we are going to practice this. And this one we just talked about it earlier, instantaneous change, rate of change, and the slope of the tangent line. We used this difference quotient already. Now we are practice the difference quotient, how to operate on it, right? So we use the concept of the function you learn in algebra class 154A and to apply it. Okay, so we are practice this skill. So if my f of x is this way, x squared minus 4x plus 1, I want to find the difference quotient. Then we just use whatever is given. It means what? We are going to find f x plus h, then f of x divided by h. You still don't know why in the world we are learning this. You will find out soon. Okay? So let's do the skills first. So difference of quotient. So how do you plug in x plus h? You just plug in the things given to you into original function in terms of x place, right? So now it's x plus h instead of x. So you have x place become x plus h. Because it's square, so that's the square. Then you do x plus 1, right? So that's your f of x plus h. Then minus f of x. F of x just original thing. That's what it is, right? Over h. Then you do your math, you FOIL them out. Minus 4x plus 1, then you minus this. Then you simplify, you should get this one, right? Do you want to see it? Okay, maybe you better see it once. Okay, so for this one would be x squared plus 2xh plus h squared, right? Minus 4x plus 1. Then you minus the whole thing. Remember to distribute your negative. Minus x squared plus 4x minus 1. Is that right? So you cancel this, you cancel this, you cancel this, right? So you have what? This left. Oops, I made a mistake. Did you see that? I say we plug in x plus h in terms of x place. So I did it for square. Take a look. Here, minus 4x. What happened? I supposed to put this x plus h in terms of x place. So I should have x plus h here. Right? So that would be the mistake you will make. So pay attention to that when you plug in. Okay? So we have what? Here x squared plus 2xh plus h squared, right? Then you have minus 4x minus 4h plus 1. That's first portion. Then minus this. Is that right? Right? So we cleaned up. cleaned up. So what do I have left? I have what? 2xh plus h squared minus 4h for the top, right? So for the bottom, what do I have? Divided by h. Then we simplify. How do we simplify? Factor the top to x plus h minus 4. Then you have h, right? So you cancel out your h. So that will be your difference quotient. That will be the answer for difference quotient. Later on, we are going to take a limit on the difference quotient, right? We did that for the slope of the tangent line and also the instantaneous rate of change. So if I take a limit of this, I can plug in h already. Because we simplify the things before, we cannot plug in the h as 0 for the denominator, but after we simplify, we should be able to, right? Let's see another example for this. Oh yeah, we did this already, I think. Let's take a look. So if my f of x equals 1 over x, how do I do my difference quotient? Yes, we did this already, right? So we find the difference quotient, f of x. That's your definition of difference quotient, right? We say h is not 0 because it cannot be 0. So we did then plug in x plus h in terms of x place. This is x place, now becomes this one. That's what we mean, right? So you plug in, become 1 plus x plus h. This one is 1 over x and h, right? Then we simplify. We said earlier, we have a complex fraction. Then we simplify it. Then, which we did earlier. Is that right? Exactly. We did earlier, and same page on the top. We just did earlier. We did this, right? We simplify this. It becomes what? Negative 1 x plus h. Just on the top of your page, and the another example we did already. So that would be the answer. Now we are going to talk about something called derivatives. Okay? What does derivative mean? It means to derive, right? So it means, what do we mean by to derive? Okay, it means to derive means what? Means you obtain something from something, right? To reach or obtain by reasoning. We do the derivative. It's a big time thing in calculus, okay? So finally, we start to talk about that. So that's the meaning, derivative. To derive something by reasoning, to reach a conclusion by reasoning. That's what we learn all about math and science, right? So we start from here. We give you a definition. What kind of things we call it derivative? So we say for a function f, the derivative of f at x, okay? So we say, what is the derivative of f at x. What kind of things we try to derive, from it, and with reasoning as well. So we use the notation derivative f prime, okay, at the time x. That's the symbol we use for derivative. It means this way. You take a limit of the difference quotient f of x. That's what we have been practicing, right? And h approach to what? 0. So we use this limit, whatever the difference quotient we give to f prime, we call it derivative. Then we just learn these limit things of the difference quotient, which is what? Instantaneous rate of change and the slope of the tangent line at the point x, right? Now we give another name. We call it what? Derivative. Then take a look. Now we are on your page 26, right? So if the derivative is defined at x, then the original function is said to be what? Differentiable. We introduce you another name, something called differentiable. Okay, I'm not going to test you on the definition of the derivatives. Maybe that's the definition, right? But something called differentiable, that's kind of complicated concept. So we give the definition, it's given. The derivative right this way. That means what? We will have the derivative, okay? We have the derivative. Actually, it's the same thing as the instantaneous rate of change, right? Right? And it's that same thing as the slope of the tangent line at that point. Did we just do that? We just did all this to find the limit for it. Now we give another name. We call it a derivative. Okay? So the derivative, look at your definition, practical definition. The derivative can be approximated by looking at an average rate of change, right? Or the slope of a second line, the tangent line, over a very tiny interval, right? So, and the tinier the interval, the closer this is to the true instantaneous rate of change, slope of the tangent line or slope of the curve, right? So from this guy, he is a German, long time ago, right? 400 some years old. So would he not invent, created, he discovered, no, not discovered, he created this notation, okay, or invented this notation. His name is what? German name, Leibniz notation for the derivative. So if I have y equals f of x, right? We say derivative is this one. We use f prime this way. Then he uses this notation. It's very handy when we do the calculation. He used this notation, d over dx. Okay, you will find out how we are going to operate on it later on. So instead of f prime here, he used d over dx, f of x. Okay, or he will write it this way. You can write d f of x over dx for a reason. Okay, so that's your f of x. Then we can also use this way. We say f of x actually is y, right? Then we use this notation prime as derivative. Then if we use in terms of that's f of x is y, then you use prime, right? Then this is your y, right? This is your y. Then you put what? dy over dx. Right? So dy over dx, and sometimes we use this symbol, little triangle, del, right? That means the difference of y over difference of x. What does difference y over difference of x? In algebra, we say y2 minus y1 equals over x2 minus x1. That's your slope. So derivative is the same concept of what? The slope of the tangent line. Okay, so all the symbols and maps, and all the symbols map to their original concept. Okay, then let's take a look at this one. That's the symbol we use. For the derivative, we use the prime, the symbol of the prime for it. Let's take a look at some example. Okay, we say find the derivative for this guy. Then it's the same thing. Derivative is finding what? The limit of things of the what? Difference quotient. So if we want to find the derivative for this function, so you use the symbol, new symbol you just learned, f prime, right? Then you use the definition h over 0, right? This for you is still very abstract, but you will get over it. Okay, just practice few, then we start to see some examples. It may make more sense later. Okay, so we say how to do the limit. So this is a fraction, right? Then we simplify our fraction. Then plug in your function. Use your correct concept, right? So x plus h in terms of x place. So what do we have? X plus h to the cube, right? Then f of x, your x cubed, then your h, right? So then you simplify this, you multiply them all 3 times. That will be, for this one, 3 times. That will be x cubed, you multiply 3 times, right? You learned it in what? 152A class, algebra class. 3x squared h plus what? 3x h squared. Don't give me x cubed plus h cubed, right? You need to multiply 3 times. Okay, minus x cubed, right? So you cancel out this. Then what do we have? So this one would be limit of h to the 0. Then on the bottom, that would be, that's a simplified. So we have what? 3x squared h plus 3x h squared plus h cubed over h, right? Then we cannot plug in because to make a denominator 0. Then we say what? We can simplify it first. So you take h out. 3x squared plus 3xh plus h squared over h, right? So you cancel out your h. Then what do we have? We have a limit close to 0, 3x squared plus 3xh. Then we try to find the limit of that thing. Can we plug in now? Yes. Right? Without making the denominator 0. So h plug in. So what do we end up? 3x squared. That's what we have. When we take a derivative of x cubed, it ends up as what? 3x squared. Let's look at an example on page 27. And it says, finding the derivative from the definition, right? From if I have a function as such. What kind of function is that? Standard form of what? Quadratic function. You learn in your 152b class, right? ax squared plus bx plus c. So the curve, if it's quadratic, it's a curve like this somewhere, right? And the leading coefficient is positive, so it opens up or opens down, opens up, right? So we also give you a graph for application. It says the graph shows the annual sales of Apple Macintosh computer for recent years in hundreds, thousands of units, by hundred thousands of units, right? So this is 0, 20, 40, things like that. Then from year 2000 to where? Year 2010. So these annual sales are approximated by the function of this. Somebody did a study during those years, so they derived of those equations. Okay, so where x stands, this is your x, right? Stands the year since 2000. Find the instantaneous rate of change of this function at when x is 10. X is 10 since 2000, so x is 10 means what? 2010. And x is 1 means what? Here means x is 1 is year 201. Okay, so we just kind of relate to this curve. Okay, they did a study. The curve looked like this, right? So let's follow from the definition first. Say, find the derivative for a. Find the derivative of what? This function. What's the derivative? Definition of derivative? We say f prime x equals what? Limit, right? H to 0 and f of x plus h minus f of x over h. That was the definition given. Then we look at the second example, see how it works out. So we plug in, right? X plus h to the function on that function. So it means what? Your x plus h will be in terms of what? X place, right? Okay, so that would be what? Your limit h to the 0. You're plugging this to that, so that would be, that's your x plus h place, right? You take a square first. Let me just color it for you. That's our x plus h, right? Then you will plug in to the function x plus h in terms of what? X place, right? That's your f x plus h. If you plug in, you should get this. Practice on that. Then minus f of x. That was that. 2x squared minus 9x plus 39, right? This is h. Then you do your algebra. You FOIL, then you simplify, right? It ends up this way. You have to do it. Make sure you do it hands-on. Otherwise, you don't make it. Okay, then we cannot plug in h as 0 yet, so we simplify. Take h out, so we have this one. Right? So we can cancel our h. Now we try to find the limit of this one now, which is what? 4x plus 2h minus 9. Can we plug in now? Yes, we can. So its limit is this guy. Right? Okay. So we use definition to find the derivative for this function. At the same time, it tells us this function, okay, which is the annual sales approximated, right, since year 2000. Then we want to find the instantaneous rate of change. Instantaneous rate of change is the same thing as the limit, right? We talk about that. We say of this function at what? At x10 and x1, right? So we find out f prime of x is what? The things we just found, 4x minus 9, right? So derivative we found, which is what? The same meaning as the instantaneous rate of change, right? Then we want to see what does x equals 10 means. Okay. We say started from x from year 2000. So year 2000 is what? Oh yeah, that's correct. Okay, well, we're talking about x equals 1. Okay, so let's take a look. And so at x equals 10, then what's your derivative? You plug in. So your f prime 10 is what? You plug in 40 minus 9 is what? 31. What does that mean? It means 10 years later after year 2000. That's your x, right? So in the year of what? 2010, that means 10 years later after year 2000. Then Macintosh sales will growing because it's instantaneous rate of change, right? It changes what? Positively. It means what? At that time, the cells, right? Will what? Growing at the rate of 31. What does 31? It's your F, right? It's by the what? 100,000 units at the time. 3,100,000. That means what? 3.1 million units per year. Okay, so at this time, 2010, they are selling instantaneous rate of change. They are selling more 3.1 million Apple computer at the time. That's what they are talking about. So if they can derive that equation, then that's what they are saying. Okay? Then look at x equals 1. So you plug in your derivative, 1, that would be what? -5. So 4 minus -5. So what is saying? In the year 2001, Macintosh sales was what? Sales will fall, right? Will falling, right? At the rate of what? 500,000, right? Or you say 500,000 units per year. Because it's a negative, it's what? Falling. So actually, look at the graph they have. It's falling, then they pick up later on. Then end up, if you graph, use your calculator graph, we learn this, right? So actually we learn the quadratic function. If the quadratic function ax minus ax plus bx plus c, where is your vertex? It opens up, right? Vertex x is where? -b over 2a, right? Which is what? -9 over 4. That would be what? 2.15. Right? So it shows what? 2.15 since you started from here. So 2.15 year, that will be your vertex. Vertex, because it opens up, you have minimal, right? So there are a curve, looks like a curve here, that they start to pick up like that. And that fits in your quadratic equation. That's what happened before. So first 2.25 years since 2000, their sales will drop. Then they pick up and grow quickly after where? 10 years later, they sell 3.1 million, right? More at the time. Got idea? I'm going to take break here and stop and continue again. I'm going to start again. Now look at your page 28. We talk about the tangent lines, the idea. You can read it through. I'm not going to test you on that. Okay? And look at page 29. We talk about how to interpret the derivative. So let's take a quick look. So far, we have emphasized the derivative as the slope of a line, right? Tangent to a graph. The interpretation is very visual and useful by examining the graph of function, and we will continue to use it. Derivatives, however, are used in a wide variety of fields and applications. And some of these fields are, used other interpretation. The following, read through, okay? The following are a few interpretations of the derivatives that are commonly used. So look at that. The first one, general, rate of change. Derivative is the same thing as rate of change at x. So if the units for x are years and the units for f of x are people, what do we have? So we will look at the derivative, the function, right? The derivative so in general, if you say f prime of x is what? Rate of change from people per year. So if x is the year, right? And the function people, f of x, if f of x is the people, right? Then x is the year, then derivative means what? The change between people per year. So the rate, that means what? How many people, changed, the total number of people changed per year. That means what? A rate of change of the population, right? So you read through all this, then you look at the bottom. What do we have? We say f of x, if f of x, right, change per x. If it's a miles, the difference of a miles, remember difference of quotient, difference of mile from here to there, then you drive in how many hours, right? So your f prime is what? Your mile, difference between miles, difference between y's over x, difference between hours. So the derivative is what? Miles per hour. So for the miles, then derivative, the rate of change is what? Miles per hour. That would be your speed, right? If say miles per second, then by the second. So miles per second, or or we say miles per hour by the hour. So the difference change miles per hour, that's your speed, right? So if the change between your speed, between your f of x over the time, miles per hour means your speed, then change per time, right? What does that mean? That means the acceleration, right? Your speed, changing speed, between changing speed during that period of time, that means what? You accelerate or decelerate. That's what it means. Okay, you can read through your page 29, take a look, and try to sink in, and especially for the business part. That would be our section 2.2, derivatives.